So in this question here, what I've got is I've got a quarter circle which I need to split the two areas in half via a vertical line, this line AC. What I need is to find where the point C is. If I know the angle theta, I can draw a radius to that point. So the key of this question is to find this angle theta. So what can we do here? Well, first of all, I recommend just trying to do what you know already. So if you look at this, we've got a quarter circle. So I can find the area of a quarter circle, no problem. So the area of a quarter circle, that's pi r squared over 4. So that's pretty straightforward. I want these half parts of the quarter circle. So basically that's the area of an eighth of a circle, which I'm just going to put up here as well. So just divide all that by 2, get pi r squared over 8. So that's fine. Now the next thing I could do is I could find the area of the sector. So area of, if I just write here sector and call it this O to B and C. So OCB. So we can see OC there. So OC, if I put B there, that's OCB. So all of that sector. So OCB. That's just a standard formula in terms of radians, and that's half r squared theta. So half r squared theta. So that's dependent on the radius and this angle theta. So that's kind of quite logical to think of that. We also know that OB and OD are also radiuses. Okay, so that's some information I've got already. So this one will come good to us. This one will come good to us. We've got that there in case we need it. Next thing to do is perhaps think about the area of this triangle. So if I take out this triangle and just draw it here, got my angle theta, I'll have a right angle there. So we're into right angles. That works well for us. And with that information, I don't know a lot other than this is a radius and angle theta. So I can find the area of that in terms of theta without having any quantities to it, and then perhaps use some algebra. So area of a triangle, simply a right angle triangle, is base times height over 2. So that, I'll call that the base and that the height, and then we use this radius. Now if I know this angle is theta, I've got a relationship I can use with height and base using SOHCAHTOA. So first of all, let's look at theta in terms of sine theta. Now what does sine theta equal? It's opposite over hypotenuse. So h over r. And then what I could do is I could get this h on its own by just simply multiplying both sides. So then I get h equals r sine theta. So that'd be my base. So let's put that, sorry, that'd be my height, sorry. So I can put that in there. So r sine theta. The whole thing will be divided by 2. And now let's find the base. So the base, because it's adjacent, will be cosine of theta. So this time I'll have base divided by the radius. That's adjacent over hypotenuse. So again, do what I did before. Just make the base in terms of the base. So then the base equals r cosine theta. And now if I put that in there, I've got a term which can represent my area of my triangle. So simplifying that off, I've got r squared sine theta cosine theta over 2. So the whole thing's over 2. Okay, that's looking good. So now what I could do is I could probably find my theta. So if I just put this here, area of the triangle, let's put that in there and call this triangle OAC. Okay, so triangle OAC, and then put in this. So I've got r squared sine theta cosine theta divided by 2. I'm going to put that like that. Okay, so now if I find the area of the sector, so OCB, and subtract the triangle, I'm going to get 1/2 in terms of here. Then that will give me some way I can perhaps find my angle theta. So to try and make that easier, what I'm going to do is I'm going to use a trig identity here. So a trig identity that's going to help me is sine of 2 theta. That equals this one twice. So sine theta cos theta plus sine theta cos theta. Just squeeze that in, that's all good. Okay, and then I can replace that for that, but only half of it, because I've only got one of those. Here I've got two of them, so then I need to do half of sine 2 theta. So this one now, I can simply replace that. Area of triangle OAC equals r squared over 4 sine 2 theta. And now I can make some kind of formula to try and work out what we've got here. So let's work out what I've got. So I've got a sector, which is half r squared theta. So that's all of that. So a half r squared theta. Subtract the triangle. So minus r squared over 4 sine 2 theta. So that one minus that one. And what does that equal? Well, it equals the 1/8 of my quarter circle, well, 1/8 of the circle, which is half of the quarter circle. So that should equal pi r squared 8. Now pi r squared over 8. Now pi is just a quantity. So maybe there's some manipulation I can do here. So this is my formula I'm probably going to need. So let's just manipulate this up a bit. So multiply everything by 8. So then I will have 4r, let's put the little line there, 4r squared theta minus 2r squared sine 2 theta equals pi r squared. So multiply by 8, multiply by 8, multiply by 8, that's all good. Now r squared is present in all of the terms. So that's good now. So theta is unknown, the radius is unknown, so I get it all in terms of theta. So divide by r squared, I'm going to have 4 theta minus 2 sine 2 theta equals pi. Okay, good stuff. Now what I can do now, I can just bring everything across, make this a function of theta, and then maybe I can use a method to try and find it. So now I can say is f of theta equals 4 theta minus 2 sine 2 theta minus pi. That works good for me. So now I've got a function of theta. So now what I could do is try and work out roughly what this angle is. So I'm just going to take this off the board here to give me some working down here, and then we'll continue on with that. Okay, right, now I need to try and work out what this angle is here. Now this is a difficult formula or equation to solve. So we're going to try a couple of values. So what I'm going to try is here, because this is going to be just over 60 degrees. So I'm going to try 1.1 and 1.2 to see if I've got a change of sign. So if I do f of 1.1 and do f of 1.2, and let's see what I get. Now, worked these out earlier, and I worked out that there's a change of sign here somewhere. So this one here, 1.1, that'll give me minus 0.358. So plug in 1.1 into here, in terms of radians again, not degrees, I get that. So it's a negative. Here I plug in 1.2 and I get positive 0.307. Now, as there's a change in sign, I must have a solution somewhere between 1.1 and 1.2. So I need to try and get a little bit closer than that, because I've not really any idea where that could be. So the best method to go here using numerical methods is Newton Raphson Method. So Newton Raphson Method. So what I would use for that is f of theta. So f of theta. And I also need which is this. Obviously, let's put that in there. 4 theta minus 2 sine 2 theta minus pi. For the Newton Raphson method, I also need the derivative of this. So f prime of theta, take the derivative of that with respect to theta, I just end up with 4. Derivative of this with respect to theta, well, the derivative of sine is cosine. So I've got cosine 2 theta. And then by the chain rule, I need to multiply the derivative of 2 theta, which is just 2. So I'm going to need to subtract 4. So minus 4 cosine 2 theta. This minus pi will disappear. Now, the Newton Raphson method is an iterative method. So what that gives me is that the theta of n would equal, n plus 1, n plus 1. So that's the next one in the sequence, will give me, will require theta n, so that's the previous value. And then I'm going to subtract f of theta, and then that would be my theta of n, and then divide that by the derivative theta n. So that's my building block to work out what I need to do to try and get an approximation. If I work out what 1.1 was, so I've got minus 0.358, I then need to try and work out what the derivative is at 1.1. So basically what I'm going to use is theta equals 1.1 for my first derivative. So theta 1 is 1.1. Now to find theta 2, we use this value. So obviously here 1, n is 1. So 1, n plus 1, that'll give me 2. So theta 2, that equals 1.1 minus f of 1.1 divided by f prime 1.1. Okay, now these values, this one I've already worked out. This one is 6.354. So I get 1.1 minus, minus 0.358 divided by 6.354. Okay, and that's giving me theta 2. Now, if I plug that into my calculator, I'll get approximately 1.1564. And that'd be my first iteration. And you can keep going and keep going and keep going, and it will stay quite close to that if you keep trying it on your calculator. So therefore, with the angle of my theta, I'm just going to offer that as 1.1564. And then you can keep going on the Newton Raphson method to see if you can get any closer. So now, just to show you what would happen, theta 3, so we've moved up to the next one, that would be now be this one, so using the method, 1.1564 minus f of that, so that would be, let's just put it in there, 4 times 1.1564 minus 2 sine, 2 times that, minus pi, and then we would divide by this 4 minus 4 cosine, and then 2 times 1.1564, and that should get you even closer. So I'm going to let you guys work out what theta 3 is. You can put that in the comments if you like, but I'm going to put that one as a rough estimate, which would be pretty close to our answer, as the angle that we need in radians for this angle here, theta. Okay.